now that we got the T-bolts done, I'm ready to start working on assembling the shaft and the gearbox. First thing I gotta do is I need to wash these bearings out. Then we'll get it roughly assembled in the gearbox. Gotta get the end play out so there's minimal run out on it. Once I get that done, I'm gonna leave the coupler off while I do that. That would be this part here and that one. This is the one that goes on the shaft. Then we're gonna see about dealing with that crack in there. I'll come up to that in a little bit. I got a little trick in mind we're gonna try out, and hopefully it works good. I'm pretty confident that it will to get me through the 2-year period that I'm looking at. The long-term plan, I am going to replace this. I'm going to be taking measurements off this. Actually, I got to do that before I install it. But I'm going to take the measurements off this and I'm going to replicate this. I'm going to make it here. We got the bearing, there's a spacer, there's a C-clip here. This one goes on the back side. Put that in here. And this one, the other end is just the bearing and the adjustment nut here. That should be fine. I'm going to let that sit a while, soften anything up in there that's kind of gelled, and give it another go. Meantime, I'm going to clean up the bearing races that this goes into. So the first half of this video is mostly about me measuring the shaft to build that one in the future. I realize that that's probably going to be boring for a lot of you, but there are a few people that I think would want to watch it, and it was the first part of this. So if you don't want to watch that, please feel free to skip ahead to where I start doing the assembly. That starts at 32 minutes and 24 seconds. So just jump ahead if you want to, and the assembly will start there. Okay, so this is going to be a bit of a difficult piece to measure because of the way that this is shaped in the middle here. It's a crude drawing, but kind of get the idea. You've got these high spots here, these 3 pieces here, and then in between there's another high spot, but it's not quite as high, and it's a wider portion of the radius. These 3 here, and these have curved surfaces on them. The other ones actually, these are also curved on the outside. It's just turned down. That's probably just the outer radius when they turned it. Then these, they're going to be tricky to machine because it's lower than this. But this portion here is lower than that, so I can't turn it on the lathe to get that round part. I'm going to have to do that on the mill section by section and just average it out till it becomes, you know, roughly around. And then we've got the channels in here. What I've got here, I've got this set up on V blocks. I'm going to take it out and measure. I'll measure the diameter here. This one I believe should be the same as that because it's the same bearing, so that should be the same diameter, which means this would be level across here in relation to my surface plate. So to get these other measurements, I'm just going to use a height gauge off of the lower one here and the higher one up here. I'll just turn it and get the height off of that, and we can calculate from there what the diameter is from center on each of these. This land here, Probably what I'll do is I'll drop a gauge block down in there or something like that. I'll probably have to use something of a known diameter, not a diameter, a known width to put in there. I'm not sure if my gauge blocks will fit in there. So I might actually use gauge pins, or I don't have a gauge pin set. What I've got is 3 wires for thread measurements, which I haven't even used them yet, but I can get the diameter of the largest wire of those, and we'll set that in here and maybe get a height that way. That's one option. Actually, another one, I think I've got some key stock around, but that might actually work better because it will sit flat. Because this here, if I do a gauge pin, it's probably going to rock and alter the measurement. So I think, I think I'm going to use the key stock. It will get a precise measurement of its dimension, then just take the height off of that. That should give me what I need for that. I don't think that one is as critical as the other two anyways, but I still want to gather it. The rest of this should be pretty straightforward. I can just collect diameters off it, and then I've got to measure the distances down. So I just got a new micrometer in. This is used, it's called an indicating micrometer, and this goes all the way down to 0.010 of an inch. I got this cheap. Whoever had it at some point, they kind of butchered it a little bit. I think they were trying to get it to fit in a tight spot. You can see they ground it with a grinding wheel here to get it down. But I've checked it out. Still seems to measure okay. You know, I've checked it with gauge blocks, and all the measurements I got were within about. Actually, this goes. It's not tenths of a thou. This goes down to 0.5 tenth of a thou. And I had all of them within 1/10. I think actually it was within 0.5 tenth. So I can't complain. There's a little bit of work I need to do on it. The locking handle here is missing. What I'm going to try and do is make something up on here. I'm not sure how I'm going to attach it, if I use a set screw or if I'm going to try and heat shrink it on there. That's a future little small project. I didn't pay much for it, so I'm not going to complain. And these are rather pricey if you buy them new. Oh, I got plenty of them. It looks like maybe 3/4. Seven, 4, few tenths here. Okay, so if I bring this right back so that line is exactly right on it, then I can read my tenths over here. Okay, so that looks like 7/10 over the 874. Now if I can get up in here. Okay, so if it's the same size, I should be able to just use the snap function on this. So I believe they're within whatever their tolerance was. They're supposed to be the same size. That one was 874 and 7/10. This one is 874 and 9/10. So that's probably within the margin of tolerance that they had on this. So I'm gonna put that down as a range on there. Okay, so I might as well get this. This is what Adam did here. This may vary because of where it's spread, though it was turned after, so I think it will come up alright. So there's about 3/10 of taper on there from one end to the other. It's a little fatter on the back. It's only 1/10, so that's not that bad. And where this is cracked, that's very understandable. This could have changed after he turned it. Also too, this is going through temperature changes right now, so that may be affecting it a little bit too. Really, I should do this when the temperature has stabilized in here, but right now at the middle of the winter, that's just not going to happen. I'm going to have to deal with it with what I've got to work with here. Okay, so make sure I'm still zeroed here and get the actual dimension. Okay, so in the center, I'm 0. We're going to read this. Okay, and we get the tenths here. Looks like 3/10 over, so 763 and 3/10. This is going to be tricky to machine. So I'm looking at the groove down in here, and so it looks like they came down like on a horizontal cutter. Let's see. Like one of these, and they came down like that, parallel on each side of the spline. But then on this here, it is also apparently parallel on these, but it's rounded in between. So they must have done multiple passes in here with one a lot thinner than this. Because it's not just square at the bottom, it's rounded. It's either that or they had one that had a concave bottom, which may be what they did. I'm going to have to try and do it in multiple passes, I think. I don't think that part is critical. What's important is the flats on these need to be parallel, especially these ones here. So if that goes a little deeper, I don't think it'll affect anything, as long as I don't go really thin and weaken the shaft. So I'll probably come up here with parallel, I'll cut both sides of the channel. Probably just come up the middle and do a sweep up the middle to make sure it's low enough. And if it goes a little lower than what I need, I don't think it'll be a problem, as long as I don't get into this down here. But that is raised up. There should be enough there that if you cut a flat across there, I don't think it's going to touch in. Okay, now I'm up to the thread relief here, and I'm just going to use verniers on this because I can't get the height gauge or the micrometer in there. It's too narrow. Yeah, for thread relief, it's not that critical anyways. Okay, so it looks like 778 there. So I want these V blocks to be exactly in line with each other, so that's why I'm using the parallel here. Make sure that they're exactly oriented parallel to each other and in line with each other. Okay, so I'm zeroed. Okay, so I have my height here, and this is in thousandths. The 5 is tenths of a thousandth. This only goes to half a thou, and I really only trust it to 1 thou. So what I'll be doing is I'll use this diameter as a reference and subtract out, let's say, it'd be half of that from this here, and that will give me my center line. So now I'm going to get this big flat. And now we'll get the high part here on the spline itself. So I'm marking it out down here to be a little clearer. So the next thing I need to try and get, well actually I'm going to get the top of the threads here. That's probably the next important one to get. I probably could mic that actually, because that's wide enough it'll span more than one thread. But let's just double check. Okay, so I have my key stock, and I just very lightly hone this with the diamond block just to make sure there weren't any raised points on it. Okay, so two sides, there's a little mark there. You can see it indented. I don't know if you can see that. Just a little ding on the surface. They're on opposite sides, and the other two sides are clean. So I'm going to use the two clean sides for the measurement, and I'll use the little ding indicators just to make sure that I have it the same way. It's actually kind of good they're there, because without it I'd have a hard time knowing. Well, I could mark it with a magic marker or something, but I would want to know which side is which in case there's a little bit of difference between from going one way to 90 degrees the other way. So with the marks, I always know that I've got the same two parallel surfaces I'm using to measure. Okay, so I had 1/87 thousandths, and I moved this to right on the line now, and I'm showing tenths. I've got two ticks there. Each tick is half a tenth, so 1/10 over. So 1/87 and 1. So now we know what our reference is. Checking that my zero is still good after I had it off. Depending on just how I lay it up, because it is a bit of a rough surface in there, I'm getting about half a thou difference in there. This only goes down, accuracy half thou, but I'm seeing it go across point from 2 inches and 198 thousandths 0, and then the low reading I had was 197.5 So that 5 tenths being within its range, so it's somewhere in there. But that should be accurate enough. So 828 thousandths for the C-clip. Okay, I did that. I think I got all my height measurements. I'm going to do this with the micrometer just as a double check. Okay, so I had it 865. Now I'm going to get the tenths. So I take this, it was just a little bit past the 15 on here. I move it to the 15 a little bit tighter, and we'll see how many tenths that is. Looks like about 5 tenths. Okay, so the first thing I'm going to do is I want to get the width of this spline. And actually, I wonder if I can get my micrometer in there. So it looks like I can get in here with this. So it looks like 181 thousandths for the width of the line here, and that came up right on the line here. You can see that. So that should be right on the 10th mark. Now this one, I don't think I'm going to be able to get in here. I think the splines are going to be in the way, the tall ones. Well, maybe. It's just barely able to get in there. I think I'm better off to go with the verniers. It looks like 420. I'm gonna start a new page on here with a new drawing because I filled up all my space on here. So I've got all my diameters here and the spline spacing and the heights of the splines. a little bit of variation in here. I think a lot of it is probably wear. Either that or I'm coming up with some crud. Yeah, now it's coming up a little more consistent that I've been around it a couple times here. I think we're going to do the rest with the height gauge. So we got 0, bottom. Okay, so I got height, I don't know if you can read it in there, 6.9490. Let me find the start of this. Okay, so I have the width of this, so I'm just going to measure the width of that groove, so I'm just going to measure the height to the bottom of it. Okay, so 5155. We'll double reference this. We're going to get this by height for the overall. Okay, so I got 4.3, 4.6, 5/10. So I was going to get that bottom groove, and I think I'll use the verniers to do this step rather than come all the way back that way. I have this length, so I do have the figure, but I want to have it from the end as well. What I'm going to end up doing, I'll probably model this out in CAD, and that'll help me get these figures as I need them to reproduce it. Try to get in that groove there, and just get the height where the groove starts from flat. Okay, so the last one I need to get is from here to here. And I did find one thing that's going to skew the measurements a little bit. This end isn't exactly flat. Where they have the center hole here, it's raised just a little bit, so this edge sits up a little bit. So I'm going to have to get some feeler gauges under there and see just how high that sits. I'm a little surprised the way they did that. Actually, I'll be able to calculate it from the offset of some of those double measurements I did. Okay, 1.1675. Okay, so I believe I have all my measurements between first page we did here and this here. I should have everything I need. I can enter all this into CAD, so if I need to pick this up in a different way, I can use CAD just to get my measurements. That or just hand calculate it. But this should be everything I need. Oh, no, there is one more thing I need here. The keyway. I need to measure that keyway. And how far up it is from the end here. And let's see, that's not going to be easy. Get the tip of the height gauge in there. I don't think this has to be right down to the thousandths, but I'm trying to get as close as I can. That should be it there. So I'm taking both ends of this, and it's mainly so I can get it centered where I cut that in. And the width of that I will take off of the actual key stock, because that will be standardized. Just use the right cutter for it. I'm probably going to have to buy a cutter for that, because I don't have one that's the right width and the right diameter. You have to have the right diameter when you do it. So I think that completes the measurements. I should have everything I need now to reproduce this, and next step I guess to start getting this installed, and we'll see how we're going to deal with that crack. Okay, so let's get started on this. So I think I got to start with it laying this way, and once I get the shaft and the gear in here, I think I'm going to have to flip it over to reach some of the components back here that need to go in. Okay, so I got to take note of that mark that I made. I'm keeping track of where that spline is. We'll line that up so the keyway is in line with it. These are both the same. Yep, both 17.55. Let's see, can I get it in through here? No, I got a roller already. Okay. So hopefully you can see alright here. Tough trying to get the camera in here and still work around and do what I need to do here. That might need a little light persuasion to get that to push on there. Okay, so I'm using a socket to try and get it hit just on the, how do I put this? I just want to get the inner sleeve that goes over the shaft, and I'm going to put the impact there, and I'm just going very gently here to try and get it on the shaft. It's just a little snug. Okay, so I got that on enough, I can get the nut on and pull it down the rest of the way, so I don't need to tap that anymore. Okay, well, I don't have a right spanner to fit this, but I think I can do this just by putting a 1/4-20 in there, and it's just a 1/4-inch hole. And this doesn't take a lot of torque, because you don't want to actually really tighten it down. It just goes till you get the run out of it, and that doesn't take that much. Basically, you just got to fight the friction of getting it over the threads here. That might actually be it right there. Alright, I'm going to move you around so you can see the dial. Okay, hopefully that shows. Okay, so I'm showing about 2/100ths of a millimeter. That would be about 1 thou. Let's see if we can just tighten that just a little bit. See what happens there. Okay, and that looks like a little less than 1/100th of a millimeter. It's about 1/2 thou. I'm going to call that good. Okay, so now I'm going to turn it around. We got a set screw here, and that tightens this little piece up here. Let me get the light on there now. So it tightens on this little tab, which is part of the threads, and it'll actually squeeze that section onto the threads and make it so it won't turn. Okay, so that should lock that on now. That will not spin free, so it should hold its setting. We should have minimal run out on it. Okay, so if I put it in neutral, it still spins plenty free, so we're not over tight. Okay, so I need to make sure I get the right one here. So that looks like the stretched out one. That's the one that Adam cut. So we're going to use that one. Okay, I'm going to have to tighten that a lot more. This takes a lot of torque to really get it down right. But it's on there. So with the crack here, what I'm going to be doing, I probably won't do it tonight. There's been a lot of suggestions about brazing and stuff, but I talked with Adam about that. I knew it was going to be an issue because of the spray weld. It would damage the spray weld. I asked him about it just in case I was wrong, but he confirmed that I was absolutely right about that. He said it's not compatible with brazing at all. He said the only way to braze it, you'd have to strip off all the spray welding that he did and completely resurface it with the brazing or something like that. I'm not going to do that. I hired him to do that spray welding on there. What I'm going to do instead is, now that it's assembled, I don't want to tighten this quite all the way just yet anyways. I'm going to stand this up on end, and I have an epoxy-like resin. It uses 2 parts and it hardens. The stuff that I have, we use it at the lanes where I work for plugging bowling balls. It's a very hard, plastic once it forms, or resin I should say, but it has just a little bit of give. So it won't crack right away, just from the slightest impact. It's meant to take the impact of the bowling ball hitting pins during bowling. So it's impact resistant, but it has very good compressibility. I actually have two of them that we use there. They're a little different. One's a little softer than the other. One has a little, and the one that's softer has a little more resilience to cracking, and the other one is harder. And if you really, after so many hits direct on, it can crack. I'm going to use the harder one in here because the big concern is the compression. What I need to do is back this up, so when this gets tightened all the way, that crack can't compress and deform inside of there. It will keep it round. So that's the idea here, and this stuff should be plenty strong enough to resist that. And I don't think it would be an issue with cracking in there because it's all going to be squeezed into place. And again, as I said, I'm only planning on using this for about 2 years, and then I'm going to replace it with the one that I'm going to make here, which will be a project coming up. So I'm going to have to mix up quite a bit more than what I need, because if you do it too small, it just doesn't work right. So these are 1-to-1 ratio. Let's see. If I do this, I can measure it out. Ooh, okay. Guess I'm not doing it tonight. Apparently this has had a reaction with whatever residual material was left in my little pill bottle, and it's pretty much hardened, so this isn't going to work tonight. So I'll have to come back with a fresh batch and try it again. So it turns out it was just too cold. I stuck this in the microwave for a few seconds and it's liquid now. Yeah, so I've cut out quite a bit of fiddling here because that bearing was a little tighter than I had anticipated. This has a fairly slow working time on it. I'm going to move the camera and we'll pour this in. So where this is a small batch, I need to really mix this good. So the hope here is that it will percolate down through that gap. So this is going to have to sit overnight. It varies depending on the temperature, the parts, and the room. Typically anywhere from half an hour to 24 hours. It really varies a lot by temperature. This is cold in here, so it's really going to have to sit overnight. I want this to really harden up solid, which takes a few days past that to get to a full, I guess what you call a curing on it. On the bowling balls, it's not a big issue. It just has to be hard enough that you can drill it, and it's good enough. But for this, I'm really going to be compressing it hard, so I need it fully cured. So I'm going to let this sit, and probably be a few days before I can get to it again anyways. We'll see what happens. I'll clean up the excess up here and tighten everything down tight, and we're going to try and assemble it. Hopefully it does the job. Okay, so it has been a couple of days since I poured this resin. It's all hardened now. I've got my Dremel tool here, and I'm just going to clean up the excess on the outside here so I have enough clearance for the block to set down in here all the way. Right now it's sitting just a little bit high because that pour came up above the surface here. Poor lighting. Shadows right in the way. I'll have to flush these bearings out again. I think I'm going to lay something over that, try and prevent it from getting in there. So I think I can just chisel the rest of that out on the top. I've cut this down to the shaft. And that should just pop off now. See how hard it's stuck on there. I haven't used this with metal before, so I don't know how well it sticks to it. Yeah, it looks like it'll pop right off of there. So I forget if I mentioned it earlier, but how I kept the resin from running down the keyways and into the bearings below is I used just a little bit of hot glue and just squirted it down the top of the keyway, not all the way down there, just enough to fill the passage up that the resin couldn't flow down through there. And that seemed to work good. I didn't see any that seeped out the underside of this. It's all clean down there. So yeah, that's how I stopped that, kept everything where it's supposed to be. So hopefully this went down in the crack nice and deep in there. It definitely penetrated near the top here because I can see that had filled in fully, but I can't really tell underneath. But everything tightened up good. I just finished torquing this down good, and everything feels good and tight. It took the pressure. I don't see any cracking in around here, which means it didn't flex any as I squeezed it. So I think it's all good. And we'll see how this all runs, but I think it's going to work fine. Okay, so now that sits nice and flush down on there, and this is ready to install. So I'm going to conclude this video at this point, and in the next one we're going to start getting this into the machine and hopefully get the knuckle and heads on as well. So anyways, thanks for watching. If you've made it this far, I hope you've enjoyed watching this video and found it entertaining or educational. If so, please consider hitting like or subscribe. It does help give me incentive to continue producing more. Thank you.